This idea of this angle of elevation is line of sight looking up. All right, elevation is line of sight looking up. Now, what I mean by line of sight is that if you have your regular old boring line of sight, your line of sight is always parallel to the ground. All right, you're always parallel to the ground. So you're always thinking of it as line of sight from the horizon up. This interior angle here is your angle of elevation. Line of sight upward. It's basically what you guys were doing down in the auditorium. That was all angle of elevation. Line of sight up. Excuse me. So this angle of elevation being whether it's from the floor, from a fixed eye point off the ground, any of those types of deals, you can use it to set up triangles. And depending upon the style of problem, it is pretty straightforward. And as of now, I know that you guys know which trig functions you're supposed to be using and all that. It's just a matter of basically really drawing your own picture. The angle of depression, on the other hand, angle of depression, oops, is going to be line of sight downward. Okay? Now, line of sight downward is the same as line of sight upward. Because if I'm looking angle of depression, that would be line of sight down is the same as you're looking back up towards it on the other side of the transversal. Because isn't line of sight parallel to the ground? No. Yes. And it's very, very easy to show this as we get into some diagrams. I mean, really the easiest thing to think of is if we stand here and look at the stop sign. The stop sign is below us, all right? So we're looking down towards it. Now, if we were at the stop sign looking up, the angle that I'm looking down to it is going to be the exact same angle as the stop sign looking back at me. They're the same, okay? Those angles are the exact same. It's just either depression or elevation, depending upon what it says. Okay? It's a very fast, quick draw in a diagram to create a triangle. Excuse me. So, John wants to know the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. How tall is said tree?
Mr. Murphy, you want to draw a picture here?
No.
Draw a picture, Mr. Murphy.
All
Draw
right.
a tree.
So, do we all know what trees look like?
No.
All right, well, good luck. So if we have a tree, we have a tree.
That's a tree.
Good morning. How are you? Pardon me, I'm trying not to talk. Osio, would you mind moving your seats over so we should sit down with you guys?
Mr. Murphy,
Yeah, but
I thought a tree is supposed to have branches and all.
squint. So, how far, when you walk out, you have to think of walking generally as a horizontal action. You don't normally walk vertically. It's very difficult. So here's your 100. And it says the angle makes a degree, what is it? 33 degrees from the ground. Which means you're trying to find what part in a right triangle. What's that? Hi, good morning. Another one here. Mr. Justin, do you mind?
What going on?
There we go. Thanks, sir. So, if you're thinking about it, yeah. Whiskey.
Are we trying to find the height of the tree?
Right. Now,
So that means the height of the tree will be x.
yes, but now if you think about it, what is it in relationship to the angle?
Or
The opposite. Remember, your angle always looks at its opposite. This is its
Adjacent.
adjacent. Can we assume that the what do you call it, the tree is making a right angle to the ground?
No.
You can go ahead and go with that one there. So what trig function are we gonna use? Tangent. Bless you. And now, just like we wrote out last week, we multiply by 100. Very good. So if I multiply out by 100, I'm going to round this to the nearest hundredth, 2 decimal places. Get x by itself. We just did it a week, like 2 days ago.
64.84.
What was it?
64.84.
64, 84? 84 or 94? Did you say?
84.
Thank you.
Oh, I heard 84.
Well, as you guys can still hear, I'm fighting the,
It's 92. It's 94,
Way to go, Mr.
like I said, my ears are still a little cloggy. And there you go. It's the idea of, can you draw a picture, fill in the blanks, and solve. That's really it. Sir?
I thought we were never supposed to assume a 90 degrees angle.
When we're talking about these things, you have to
Me?
you kind of have to, because are you gonna listen or are you just gonna go back on it?
Yeah, I'm listening.
You kind of have to because you don't know any other way to do it. So, all right. Same idea here. A building's 50 feet high. Excuse me. The building is 50 feet high. Sorry that I didn't blow this up very well. At a distance away from the building, an observer notices that the angle of elevation to the top of the building is 41 degrees. How far is the observer from the base of the building? If you're from the base, are you above the building or below the building? Yeah, so you're on the ground. Okay. How far are you from the building? So you've got a building. How tall is the building? Okay. And this angle here is how much? And you need to solve for that. What are you going to use?
Oh, broke on views.
You're going to use tangent again. Okay. Now, don't fall into the pigeonhole idea that it's always going to be a tangent, because it might not be. All right, it just so happens the first couple wind up that way. Bless you. So, the x value, is that our opposite or our adjacent?
It's our
Adjacent,
adjacent.
good. So we know that the tangent, 41, is 50 over x. Now, when you have to get x by itself in this case, what do? You divide it. Remember, this is the exchange-o, change-o. Oh, so you're pressing the button. What do you got?
57.52.
All right. Again, this is just extreme. I don't want to say extremely. It's very straightforward application of what we're working on. Elevation depression is such a very common thing that you'll see. Now, Reagan, you said you took a practice SAT this weekend. You were saying that you saw the sine, cosine stuff on there. What kind of stuff was it?
The sign of course.
Well, it's good.
I forgot my calculator, so it gave us like the dollar calculator, so I couldn't figure out how to work it.
Oh, that's awful. That's awful. All right. Let me show you some other examples here. And I think.
I can bring it in. I have like the practice.
Oh, you do?
Yeah,
I'd love to see it. I'd love to see it. A bird is on top of a lamppost. Wow, this really didn't blow up at all. Sorry about that. The angle of depression from the bird to the foot of an observer standing away from the blah, blah, blah is 35 degrees. So, bird on a lamppost.
doesn't tell us how to make the roof. Nice.
Hey, for those of you that are new, welcome, and I'm an awful drawer.
That actually kind of does look like a bird.
Thanks.
Not the big roof.
So-
It's like,
Like that little.
I don't know.
Angle of depression to the person standing out here. Now here's where things get interesting. You want to figure out how tall the lamppost is, okay? You know that the distance from the bird to the observer.
Wait, the person is standing directly underneath the bird?
I hope not.
Just
Hopefully the wind is blowing.
Yeah. So toys listening.
Let's just say that this is the horizontal distance,
Shut up.
and it's 25 meters. Now here's where it's kind of weird. When you talk about angle of depression is from where the bird is looking downward. So the angle of depression is the exact same thing as the angle of elevation. Yeah, so you just, when it's up here, you just switch it to the other side. So now what I want you to think of it is, they're alternate interior angles. Okay? That's all they are. They're alternate interior angles, and that's how they switch along that diagonal. So this gives you your 35. So now you have an adjacent, and you're trying to find its opposite. Gee, it's a broken record. What are you going to use? And we always write out what you're going to put in your calculator before you put it in the calculator.
Why
Yes,
is
sir.
that?
Oh, I put it down here and I said, let's make this the horizontal distance, because I don't know how we're gonna measure that. I can't throw a tape measure out to it, you know what I mean? But I know that I can walk 25 meters away from the pole. And you're right, sometimes it is kind of misleading, but if you wanna think distances are generally measured horizontally. Always think about a tape measure. Okay. What do you get when you do that?
17.51.
17.51? Now, do you guys know how many feet are in a meter? About 3-ish. If you multiply that by 3, you're going to get, what, 41 feet or so? 50. Yeah, that's kind of a tall lamp. But here you go. Okay. Now, let me give you ones that actually have, which one is it? This one?
Let's go up.
Yo, bones. Check the shoes.
So you don't have to keep writing these out.
He said it's so perfect.
What's your
You know, that was fun to watch. I mean, I didn't really know. I was mainly hanging out with my kids. You know, if you think about, hold on guys, if you think about, all right. 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? Now in this case, there's my wall. Where does the 14 go? It's the hypotenuse, because it's the ladder. The ladder is what's being leaned up against the wall. So you have to think about it. Sometimes you will have to use that hypotenuse. So the 14-foot ladder is there. You need to figure out what the angle is. What trig function do you have to use then to find?
Sine.
Very good. So sine. And then how do you write that out?
Sine over -1.
theta is sine -1, the inverse. What was the angle you guys were getting for that then?
68.21.
Was 68.21? Oh, you can sign that inverse.
Oh,
Okay. Excuse me. Makes more sense now, doesn't it?
Yeah.
And that's the idea here. Oh, so let's say you did that on the test. You wrote this out, but you wrote down 0.2.
Okay.
And I go, oh, so you know what you're doing, but you push the wrong button. Now, then you take off half a point. But it's not fully, you know what I mean?
Yeah.
Writing this stuff out saves you points. That's what I'm getting at. A ramp is needed to allow vehicles to climb a 2-foot wall. The angle of elevation in order for vehicles to safely go up must be 30 degrees or less. And the longest ramp available is 5 feet long. Can the ramp be used safely? So let's see here. We have a 2-foot wall. We need to make sure that our ramp, the longest ramp available is 5 feet. So the ramp would be 5 feet. The 2-foot wall is here. What can I do? Will that theta value work? Can I get it under 30 degrees? Well, maybe. Well, what trig function are you going to check? Sine again. So is the sine of theta 2/5? So then theta is inverse sine of 2/5. Does it wind up under 30 degrees?
Yes.
What do you get? 23.6? So yes, that can be safely used to get over the wall. All right. That's kind of the setups here, guys. It's not so much just, hey, here's a triangle solved for the missing side link. Can you draw a quick picture and go for it? All right. Not terrible, is it?
Yeah, it's terrible.
Everything for you, Whiskey, is terrible, so that's okay.
I mean, I'm in school.
All
I'm
right.
supposed to enjoy my life when I'm stuck in hell.
You in hell? You in hell?
Finish it.
What?
Yeah.
Just to give you guys a little bit of a hint then for 7. If you are going to your friend's house, and his house is 30 feet up in the air, and you're standing here with your super soaker, very long legs. You're standing here with your super soaker.
It's the super soaker.
Your super soaker.
It's pretty good.
Thank you. You squint, it looks better. If the super soaker is, yes, squint and close your eyes,
Maybe like
is already 6 feet up in the air, how much further up does the super soaker have to shoot? 24. So what you're really doing here is using 24 feet, and you're trying to find, what is it, the angle you're trying to find there? And you want to know what's the angle that you have to be shooting up at for the super soaker to reach. Because as you all know, super soakers can shoot very far if you have a good super soaker. If you buy a cheap super soaker, it won't work as well.
Waste all your money.
How far were you from there? I don't remember. Was it 30 feet? 15? Wow. Because actually, we just bought Ryan a super soaker because it's February. You might as well get him a water gun. So, and I think it said on there it shoots up to 60 feet or something like that. So I'm like, huh. You gotta have a cool super soaker.
60, man, that's pretty
I'll use a power washer.